today's session I'm going to talk about Pythagoras theorem and some basics of trigonometry. So let's continue. First of all, let's study or let's learn what Pythagoras theorem tells us. So first of all, let's talk about Pythagoras theorem. So whenever we think about Pythagoras theorem, we have to think about a right angle triangle. So it is a special kind of triangle whose one angle, at least an angle, is 90 degree. It's at most, not least, because triangle cannot have more than one angle 90 degree at the same time. If two angles of triangles are 90, so that means triangle is not formed, because what happens is, if two angles are 90, then these two lines are parallel and they never meet each other. So if they never meet each other, they will not form a triangle. So a triangle can at most have only one angle 90 degree. So right angle triangle is a triangle having an angle equal to 90 degree. So the side opposite to this 90 degree is the longest one, and it is called hypotenuse, and perpendicular and base, so they are relative to the reference angle. So what that means is, suppose if you are looking from this angle here, then side opposite to this angle will be perpendicular and it will be base here, and if you are looking from this angle here, then this side will be taken as perpendicular and this will be taken as base, and this hypotenuse is always the side opposite to 90 degree, and it is the longest one. Now what Pythagoras theorem tells us, that is, the square of this hypotenuse is equal to the sum of squares of other two sides in right angled triangle. So this is what the Pythagoras theorem tells us. So this is all we need here. We have to identify H, we have to recognize P and B with respect to our reference angle, and then we'll define some ratios here. So there are 6 trigonometric ratios. Basically we'll talk about 3 trigonometric ratios first, and then we'll define their reciprocals. So let's start with that. So in the right angle triangle, let's consider another triangle here. It is 90 degree here, this is theta, so this will be H, this will be P, and this will be B. Now let's define sine theta. So sine here, its full form is SIN, sine. In short we write SIN only. So this sine of any angle theta is the ratio of perpendicular to the hypotenuse. The ratio of perpendicular and hypotenuse in any right angle triangle, that is sine theta. Similarly, cos theta is defined as, so this cos is COSine, cosine. So why cosine, I will explain about this later. This cos theta is equal to, it is defined as the ratio of base and hypotenuse. And here this is tan theta, it is defined as the ratio of perpendicular over base. So this is tan theta. Now the full form of tan is tangent. Now we'll talk about y sine and cosine. So this cosine simply means this is complementary to the sine, okay, complementary of sine. So you can understand in this way. Now what are complementary angles? So complementary angles are the angles whose sum is equal to 90 degree. Now what happens in case of sine and cosine is, whatever the angle is there, if you take its complement angle, then the trigonometric ratio of sine of one angle and cosine of another complementary angle will be equal. So basically what I am saying is, whatever the value of sine 30 will be, same will be the value of cos 90 minus 30. The complementary of 30 is 60. Similarly, whatever the value of sine 10 is going to be, the value of cos 80 will also be same. Sine 10, cos 80. 10 plus 80 is 90. These two angles are complementary angles. So that is why cosine refers to the complementary of sine. So similarly, you can try with all other angles whose sum is 90 degree. Vice versa is also true. So now let's define the reciprocal of sine theta. So that is cosec theta. Now this cosec theta comes from the secant. Secant is reciprocal of cos. So here cosecant. So from there we take only the part of this and we define cosec theta here. So this is cosecant, means complementary of secant. So the concept is same as in case of cosine here. So complementary angles will have equal values for secant and cosec. Now this cosec theta is defined as the reciprocal of sine theta and it will be s by p. Similarly, secant theta is the reciprocal of cosine theta and that will be equal to s by p. Similarly, cotangent. So in short we write cot theta. So the concept is same here also, complementary of tangent. So that means whatever the value of tan 30 will be, same will be the value of cot 60. 60 and 30 are complementary angles. So that is the same concept here. So it is the reciprocal of tan theta here. So this is p by b being tan, 1 by tan will be p by p. So these are 6 basic trigonometric ratios here, and these things are related to a right angled triangle. So we have to consider a right angled triangle. So now let's go for another. Okay, let's continue. Okay, let's continue with this. So now let's consider the Pythagorean relation here. So that is p square. So let's create another one. Sorry. Okay, let's consider Pythagorean relation, that is p square plus b square is equal to h square. So let's divide both sides with h square. So what we'll get is p square plus b square divided by h square is equal to h square by h square here. So let's split it in this way. We can do that. This is 1. So we know that in basic algebra, in rational expression, we have studied that if it is a plus b by c, so we can write it as a by c plus b by c. Simply the same thing has been done here. So now this p square by h square is p by h whole square. Now why? Because in laws of indices you must know that if a by b has power x, then it can also be written as a to the power x divided by b to the power x. So this is how the whole power can be distributed inside the bracket in case of division. So vice versa is also true. So the same case here. Now here this is b by h whole square. This is equal to 1, and this p by h being sine theta, so we'll write it as sine theta whole square, and here cos theta whole square, and this is equal to 1. So we can write this as sine square theta plus cos square theta equals 1. So this is an identity. This is how we get this identity. Similarly, we can divide with b square and p square turn by turn, and we get other two relations. Sec square theta minus tan square theta equals 1, and cosec square theta minus cot square theta equals 1. Hope this is helpful to you all. Thank you.